So you should have your highlighters, calculator, pen, pencils, everything you use for your notes so that we can get started right away. Now, exponential functions. If you have ever been to Magic Mountain, take a moment. Have you been to Magic Mountain? And now think, if you have gone to Magic Mountain, have you ever been on the Superman ride? The Superman ride, if you can't remember which one it is the one that starts off very flat and then just takes off, right? Kind of like Superman. It just takes off. Well, this is what an exponential function looks like. An exponential function goes up and up and up forever and ever and ever. Now we know the Superman ride eventually ends and comes backwards. Very interesting ride there. But notice, this is not a line. It's not linear. It actually curves out. So again, one of the things that we have to know for today is the difference between an exponential function, which looks like this, and of course, what is linear. And that's actually one of the questions that's going to come up first. So an exponential function, here's the topic of the day. Yes, it does say the word exponent, so there is something special about it. So an exponential function is a nonlinear. Yeah, we saw that, we just mentioned it. A nonlinear function of the form. All right, so here it is. Here is our equation for an exponential function of the form y is equal to a times b. But notice, here's what makes it exponential. It's got a power of x. And that's the main reason right there. This little power, that's the main reason we know that something is exponential. So we're going to write this off here on the side. The variable is the power. See, everything we've done up to now, it's always been a number up there. Yeah, but for the very first time, the variable is a power. And that's really the shortcut to knowing if something is an exponential or not. Just that by itself. In fact, some of your homework, just knowing this, you can already answer about 4 questions in the homework. Now, the exponential function also gives us some very important information. One, yeah, that's our power and it's an x. That's why it's exponential and not linear. But this right here, the a value actually represents the y-intercept of our graphs. We are going to be graphing today, so our y-intercept is represented by whatever a is. And this equation does come with some restrictions. One of the first restrictions that we get is that the only number the a cannot be is 0. And it makes sense. If your a is a 0, 0 times anything, well, everything would disappear and it would stop being an exponential function. So the only a right there that we can't use is 0. So I'll never have that as a y-intercept, at least not for this basic parent function. Now the b value, well, the b value gives me some more information, but there are some restrictions to the letter b. For instance, one of the first things you have to know about the letter b is the b can never be the number 1, actually. See, think about it. 1 to the power of 1 is a 1. 1 to the power of 2 is still a 1. So 1 to the power of 1 is 1. 1 to the power of 2 is still 1 because it's 1 times 1, so it's 1. 1 to the power of 3 is 1 times 1 times 1. Well, guess what? It's a 1. Anything with a base of 1, look, 1 to the power of 20, still a 1. That's why this concept of an exponential function doesn't work if the base is 1. It also has one more restriction. So first of all, the b will never be a 1, and there's actually another rule. The b has to be greater than 0. So that base has to be, well, if something's greater than 0, it just means one thing. It's got to be positive. It has to be a positive number. Okay? So a couple things. How do we know something is exponential? The power is actually a letter. My y-intercept is whatever's in front. Notice the y-intercept has no power, only the base does. and your base has to be a positive number, except for the number 1. So those are some of the basic ideas of an exponential function. Now, we had a picture up here earlier, so you know what? Let's add it in here too. So we have an exponential. Here's the other interesting thing about an exponential function. Remember, that is whatever a is. That's where I'm going to touch the y-axis. Always going to touch there. But here's an example of an exponential function. Remember, it's very flat, but it actually never touches the x-axis. That's what's interesting about an exponential function. It's right above it, never quite touches it. See, it never touches the x-axis, and then it goes up and never comes back down. It just goes up forever. And then over here, it goes forever this way, but it never touches the x-axis. Call it an asymptote, something that's going to come up later on in math, but I thought we should see it now. But again, look at your y-intercept. Your y-intercept is that a value. So here's where the questions come up. In your homework, they're going to ask, is something an exponential? Yes or no. In fact, when you get your assignment, just want to show you here. Look at this question. Just want to show you in the homework. Determine whether this equation represents an exponential function. Well, there's only one place you should look. And this is why when you look at your homework, it says the variable is the power. There's the variable. Is it a power? Yes or no? Well, look, you're either going to choose, you're going to say does or does not. Those are your two options on BIM. Well, then the variable is a power. So then my answer would be does. That'll be my choice right there. So it does. But then it says explain the reason. Well, the reason it's this is because it follows that y is equal to a times b to the power of x, because my variable is the power. So there's number 1 in your homework. Eventually we'll bring that back out so you can see it. But that's all you're doing. That's what I'm telling you. Your homework today should be very quick for some of this. And knowing some of those basic facts will make it that much easier. All right, so moving right along. Let's do the examples now. So example number 1 says, and you have questions like this on that homework too. Does each table represent linear or exponential? Well, this is again why we always tell you to get your word wall. It comes in handy. And let me show you a box in your word wall. This is in unit 6. In your word wall, we have them side by side for you. You are comparing an exponential versus a linear function. It says the variable is a power. Well, not over here. The variable is just a regular old letter. It's not a power. So that's one thing we should tell them apart with. Look at the graphs. The y-intercept is your A, while over here the y-intercept was your B. This is a curve. This is a line. Very different. And then it says the y terms. I wrote pattern. We're going to get to that. The pattern means if it's exponential, you're doing multiplication or division. If you are adding or subtracting, that's when we have more of a linear pattern. But again, this right here, adding little words like this, variable is a power, but this, the word pattern, that's actually what we're going to use today, or right now, actually. So here we go. So example number 1, does the table represent a linear or an exponential function? And then explain. All right, well, look, we're going to look for a pattern. The x's. So we're going to check out the x's for both of these. When I look at my x's here, they are going up. Well, numbers can only get bigger, right? For both of these, numbers can only get bigger with adding or with multiplying. Well, clearly they're adding a 1, adding a 1, adding a 1 on that list of numbers. We've done this before. We've done patterns. Here, well, same pattern. We're adding 1. So the x really doesn't help me much right now. But that's why our word well said, you got to look at the y's. The y's are going to make that decision for us. Well, then I'm going to look for my y values. So I'm going to try to find a pattern. Now, I notice they're getting bigger and bigger and bigger. Again, that's adding or multiplying. Well, let's see. 2 times 2 is 4. 4 times 2 is 8. So no, that didn't work. That should have been an 8, not over here, but here. Well, then the pattern for this one, they're adding by 2. 4 plus 2, 6 plus 2. All right, well, there it is. It's very consistent now. So because it is constant, right? You're adding here according to the word well then, this is a linear function. And I'm going to say there is a constant rate. Constant rate of change. By the way, we're basically saying it's got a slope. And the increase, because we're adding, it is an increase by 2. Now, in Big Ideas Math, they're going to have some of these questions like that. All you have to do is click on it. You're not even going to have to type it in. You're just going to click on things like this. But there it is. I'm done. It's linear because I was adding by the same number over and over and over. It's called a constant rate of change. And it's increasing by 2 now. Don't forget, we were adding. Okay? Now, when I look at the other one, when I look at my y values here, well, let's see. My numbers are getting smaller, smaller, smaller. Sorry, what am I talking about? My numbers are getting bigger and bigger and bigger. Now, the question is, how are they getting bigger? Well, look, 4 plus 4 is 8. 8 plus 4 is not 16. Okay, it's not adding. Well, then maybe it's multiplying. I'll put the dot. 4 times 2 is 8. 8 times 2 is 16. There it is. We found the pattern. We are multiplying by 2. But you see, that's the difference. If I'm adding or subtracting, it's linear. Because I'm multiplying, now it becomes exponential. It's a curve now. It can't be a line anymore. So there is no constant rate of change. So it is not constant. So there is no constant rate of change. It's multiplied. It is multiplied by 2. Because that's what we did. That's the pattern. So we're describing the pattern as we go. But again, you have 2 questions like this on your homework. When you do your page 13, look, you see, the tables look a little bit different, but it's the exact same question. All right, so you're going to answer it the same way. All right, and then you have 2 problems to try out down here on your own. Here's the one I do want to talk to you about. This one right here. So I'm going to talk to you about practice problem number 1 because it came up earlier in the other class, so I want to talk to you about it now. When I'm looking at my pattern here, yes, they're going by 1. Yes, they're going by 1. They're going by 1. But then here they're getting smaller as you go along. The question is, things get smaller with subtracting or with division. So if that's the case, 8 take away 4 is 4. 4 take away 4, that should be a 0, so it's not subtracting. Then that means division. Look, divide by 2. Divide by 2. Divide by 2. So is this exponential or is it linear? Well, it's division. Then we know it is exponential. And because of the pattern, right? We had our pattern going. And the reason it's exponential is because we were dividing by 2. There's the reason. So yes, just remember, I know we hadn't seen a division pattern before. That's why I wanted to do that one with you. But that's how we decide if something is linear and exponential. Now, before you do the practice problems, I want to show you example number 2. So we're going to go to example number 2. All right, here it is. Evaluate. Now, when we hear the word evaluate, we saw this the other day. Evaluate means use a calculator, work things out. These are numbers. You are going to work them out separately. So here's my equation. Y is equal to negative 2 parentheses 5, and then it has the power of x. That is why this is exponential. This is exponential because it has that power. And then they said, oh, by the way, the x is a 3. Well then, take a moment. Y is equal to negative 2, parentheses 5, and remember, it's not times 3, it's a power of 3. Now, I might have written it a little too small there, but there you go. But there's the power of 3. So now, this is where you let the calculator do all the work for you. Now, remember, you have to type it in exactly the way you see it. So, remember, this is our power button right here. You get a different colored pencil so you can see it. That one right there, that's our power button, the one that points up. All right, so here we go. So it says negative 2 on the calculator. Oh, sorry, there you go. Negative 2 on the calculator. There, now we can see it better. Negative 2 on the calculator, parentheses 5. There's my parentheses with a 5. Now it needs a power of 3. So the power button, and then with a 3. And just like that, let's hit enter. And there you go, negative 250. Just type it in exactly the way you see it. Negative 250. Done. All right, let's try one more there on this page, and then you'll do those practice problems, maybe some of the classwork, maybe some of the homework right away. So we're going to give you a little moment to try some of these out. So here it is again. Looks like they forgot the Y on that one. All right, so here we go. Look, there's my X. There's the X, then that's where I'm going to write it. 3, 0.5, and then it's a power of negative 2. Then yeah, throw it in there. And yes, you are allowed to throw negative powers into the calculator. All right, so here we go again. I'm going to type it in exactly the way I see it. 3, parentheses, 0.5, close the parentheses. It's time to press the power button. Press your power button, the one that looks like that, pointing up. And don't forget it's a negative 2. Don't put minus, put negative 2. Hit enter, and just like that, the calculator has done all the work for us. Okay? All right, so right now we're going to give you about a 10-minute little break. One, so that you could try these problems out here at the bottom. So you got 4 of them to try out. The mentors will help you out for the classes with mentors. But once you do these 4, don't go on to the other side yet. If anything, you can now do half of the classwork. On page 13, you can now do 1 through 4 because it's just what we did right now. On the homework, you could actually already do the entire front page of the homework. And don't forget, we already did this one here, and I can leave it up for a little moment. All right, so we're going to pause the video. We're going to give you 10 minutes to finish the You Try problems. So you're going to finish the problems there on page 10. And if you do finish those, then do a little bit of your classwork, do a little bit of your homework. All right, so we're going to pause the video. So you take a moment to work on these problems right here. All right, so we're going to check your answers now. Make sure you understood the concept. So if you did this one correctly, let's see, you would have seen that the pattern is to subtract a 1, which means if we're subtracting over and over and over, which means if you're subtracting over and over and over, this is now linear. So you should have said linear. And the reason is that we subtracted by 2. All right, and if you did these correctly, let's see, you should have said 2 times 9 to the power of 0. And by the way, you cannot multiply these first. Powers are first according to order of operations. But when you throw this into a calculator, my answer is just a 2. And remember, that's because anything to the power of 0 is just a 1. That's why we're left with the 2. And if you did this one correctly on a calculator, 1.5, 2 to the power of, they said negative 2 right there. And if you did it carefully on your calculator, you should have got an answer of 0.375. All right, so we're going to finish the rest of the notes here. So flip the page. Once you're ready, you should have just checked your answers right now because you had time to work on it. Again, you should have already worked on the classwork and some of the homework. So right now we're going to do our last page of the notes. That way you can finish everything off and have plenty of time to catch up, get everything done. Again, you should have no reason to have any missing work because you're getting a lot of class time to finish this. So last page, we are actually going to do a little bit of graphing. So when you look at your graphs here, look, when your A is greater than 0, again, look at the graph, Superman ride, it takes off, but it could also head down forever and ever, just like this. We have the one here where the graph is actually decreasing. I like to think about a plane in this case. And when I'm thinking about a plane for these problems, I have a plane that is landing on the runway, while over here the plane is taking off. So there are two types, of course, that we can have, and then they could be flipped over. So things can be flipped over. Things are either taking off or landing. Just depends how you want to think of it. So for the first picture, okay, in our first picture, we're going to write our equation. Y is equal to A times B to the power of X. We've already mentioned a couple things. We have already said that the A value is the y-intercept. And remember, your y-intercept is where our graph touches the y-axis. That's why here it touches at a positive A. Here it's touching at a negative A right there. And when I look at my other graph, we'll look at the equation. Y is equal to A times b to the x. And when people see that, they say, well, if they're all using pretty much the same equation, then why are there 4 different graphs? Well, again, the easy thing to spot is the y-intercept. So there are questions on the homework where all you're going to do is pick from 4 graphs, look for the y-intercept first. That's going to help you narrow down your choices. It's the b value that determines which one we're going to work with. So if my a is negative, look, less than 0, they're going to be at the bottom. If your a is positive, they're going to be on top. So here we go. Let's talk about the b value. It's the b value that really gives us more information. So if your b value, so this one right here, this is why we have 4 different graphs. The a will tell you if it's on top or if it's at the bottom. All right, but here's the b value. It says b is greater than 1. So what they're saying is if your b is bigger than 1, then we are going to have what we call an increasing exponential function. That's why it's taking off. Look, it's like an airplane. It's on the runway, and then it takes off. Okay? Again, this is taking off kind of in the negative direction. Think of it as a submarine. It's diving down. It's taking off from where it was. So when something is taking off, it's increasing. Then when I look at this one, here's the difference. The b value, let me see if I can zoom in a little bit more there so you can see it. The b value is actually between, well, remember, you can't be less than 0. You can't be negative. But it's between 0 and 1. So if your b is between 0 and the number 1, if your b is between 0 and the number 1, which is what this is saying, then it is decreasing. It is landing. Think of it that way. So my plane is landing on the runway. My submarine is coming back up and making its way back to sea level. A lot of different ways of thinking about it. But that's what we're looking at here. So the b value is going to tell you if it's increasing or decreasing. The a value is a y-intercept, but if the a value is positive, you're going to be on top. If your a value is negative, your graph is going to be at the bottom of the x-axis. All right, so we're going to draw our own here. Now, the easiest way to draw our own when we don't know what things look like is to make a table. And this is why I needed you to practice with your calculator. So it says graph and compare to the graph of the parent function. All right, so my concern right now is, can you even graph? Well, here's my equation. I do see that my power is an x, so I'm not going to be drawing a line. Because the power is x, it's going to look like one of these. Look. And now this is not the graph that I'm going to do. This is what they call the parent function. It's the original, the OG. See here, they're putting a 4 next to it. So something's going to happen. All right, first things first. Here's what we learned earlier. That's my y-intercept because whatever's in front is my y-intercept. So I can even draw that into my picture already. And we now know that if this number is bigger than 1, and it is, this is going to be increasing. That's why my graph is going to be taking off, like a plane taking off. Well, look, we see that here. It's going to look like a plane taking off. All right, but this is why you have a calculator where all you're going to do is plug in. So you see the first number I'm going to plug in, that x, I'm going to plug in all these numbers now. There's a shortcut. So eyes up, pay attention here. We're going to do exactly what I did earlier. We're just going to plug in. Okay? So here's my calculator ready. Let me zoom in a little bit more. All right, 4, parentheses 2. There it is. I'm going to press my power button. All right, here comes the first one. -2. Not -2, -2. And I got an answer of 1. Okay, right, a 1. Now, instead of deleting everything, again, that's why I need you to look up. Before you delete anything, you have all these arrow buttons right here. All these arrow buttons. So all I'm going to do is I'm going to press the arrow button up and I'm going to go over. Why type the whole thing when all I need to do is change it to a -1, hit enter, and there's the next number. Now it says plug in a 0. Now we actually have the answer for that. So I'm going to type in a 0. Whoop, 0. Now I got to get rid of that 1. There's a delete button right there. There it is, power 0 now. Look, we already know the answer is 4. That's called my y-intercept. There's the 4. All right, well, let me go back up there again. Move it over. Put a 1 now. And there it is. There's my answer, 8. And finally, they want me to plug in a 2. Okay, well, use the arrow buttons. Don't type in the whole thing when you can just do this. Oh, it's not a 12. Let me delete that. There we go, just a 2. All right, so I got a 16. All right, we're ready. I have all these numbers. My only issue with this is be careful with your graphs. Look at what they're doing. They're not going by ones. If you look carefully, they're skip counting by 2. And that's where they'll get you, so watch out. First one, -2, +1. -2 first. So you see, you got to be right in the middle there. Remember, they're skip counting. Look at the next one, -1 and then 2 up. There's -1 right here in red, and then 2 up actually puts me right there. 0, 4, okay, that's easy. I already have that. 1, 8. Don't go all the way over here. 1 is right there. Remember, they are skip counting. They said go up to 8. There it is. There's my dot. And then 2, okay, no skip count there. Just go to 16. All right, there it is. Remember, it is like a plane taking off. That's why the plane never technically touches the ground. The wheels do. But that's why you always have to have that little space right there in between. There it is. There's my graph. So if you notice, because of the 4, we call this a vertical stretch. This is a vertical stretch by 4, because that's what everything got multiplied by. Everything was multiplied by 4, based on 2x, 2 to the x. All right, but again, the calculator did all that work for us. You just have to know how to graph very carefully. And if you end up drawing a line, you know you made a mistake. These are exponentials. All right, one more here, because the others you're trying on your own there. -1/2 to the power of x. All right, this is exponential. There's my power. Well, these are all the powers they want me to throw up there. But luckily I'm not doing these by hand. we're going to let the calculator do the work. So I'm going to delete it all. Negative, not minus sign. Negative button, parentheses, 1 divided by 2. So again, eyes up, eyes up. It says 1 divided by 2. So type that in, 1 divided by 2. Close your parentheses. It's a fraction. Make sure it looks like a fraction. Now it says power. Okay, here we go. Negative 2. Negative 2. If you're doing this right, you should have got an answer that said negative 4. I need you now practicing along with me. So negative 4. Okay. Now I'm going to put a negative 1 up there. Use your arrows. Again, this is how we make things easier, but you have to get the practice in. You should have gotten a negative 2. All right, we're going to throw a 0 in there now. We already know what the answer will be. At least I have an idea what the answer will be. There's the 0. I'm going to delete the 1. All right, there we go. My answer is negative 1. And by the way, that makes sense. There's an invisible 1 there. My y-intercept is 0, negative 1. That's why it's here in my table. Oh, and I almost forgot. Look at this number, 1/2. This number is not more than 1. It is definitely, just like it says here, between 0 and 1. So this is a decrease. If you can tell yourself this info in advance, you might be able to make sure your graphs are correct. But anyways, let's keep going. We're plugging in a 1. There's my 1. All right, so negative 0.5. And yeah, just write it in. Don't worry about rounding, none of that. Just write it in. And then last one is, we're going to throw a 2 in there. Negative 0.25. Just write in. If you want to call it negative 0.3, go for it. All right, I'm ready. I'm going to start drawing this thing out. So, negative 2, negative 4. Let me zoom into this graph here now. Remember, let's see, are they skip counting? No, they're not, actually. Look, here's 1, 2, 3, 4, 5. Okay. Are they skip? No, they're not skip counting here either. 1, 2, 3. There's the 4. All right, no skip counting on this one. Perfect. Makes it easier. Negative 2, negative 4. Negative 2, then you go down 4. There's the only dot you should be putting. Negative 1, negative 2. Negative 1, negative 2. 0, negative 1. 0, negative 1. There we go. So far, so good. All right, here come the weird ones. If you want, just look up for a moment, and then I'll pause so you can catch up. 1, so positive 1, and then down 0.5. That means you don't even make it to 1, like somewhere in between, right in the middle. And then it's 2, and even smaller than that. Remember, it never touches the x-axis. So this is our submarine coming up, back up to sea level. And there we go. There's our graph for this one. So again, the calculator does most of the work for us. We just have to be very careful with our graphing. You know what? There is one last thing I want to mention. I want to mention it about number 5. Oh, sorry, just in case you were still writing there. Remember, that's what it should look like. There we go. But we have the calculator did all this for us. So here's the last thing I do want to mention. So again, we're graphing. You have a couple problems like this on your homework. Remember, the number in front is your y-intercept. So that means that's 0, 5. You already have it. It's right here. You don't really even need to plug that one in. It's already there. But because my number right here in the parentheses is bigger than 1, this is going to be an increase. If we can break it down like this, it does make the math and the work a little bit later on a lot easier. So now you can let the calculator do it for you. In fact, look, let's just do one more. Calculator ready. All right, here we go. 5 parentheses 2, power. All right, here it is. Negative 2. 1.25. Okay, 1.25. All right, now we're going to go back up. Change the negative 2 to a negative 1. 2.5. Okay, 2.5. We already did the 0. Look, it's already there, but if you need to type it in, go for it. But now I just need a positive 1. So I could go back up there and just delete the negative. All right, I got a 10 for that one. And then I'm going to put a 2 up there. And the calculator, if you're doing this right, you should be getting a 20 for it. So now here's the reason why I wanted to bring this problem up. So look, here we go. Now, negative 2 and then positive 125. So let me see if they're skip counting. They are skip counting again. We don't really like that too much, but they are skip counting. All right, so those are our numbers. All right, so here we go. Negative 2, and then you go up 1, so that's halfway, and then just a little bit more. So you don't have to be super precise. Just make sure it's not at 2. This one, negative 1. Well, negative 1 is right here. Don't forget their skip count. You got to go in the middle. And then it's 2.5. 2, so just above the 2. All right, the rest are easy. 0, 5. 0, well, that's still skip counting. Try it in the middle, so maybe not so easy. 110, well, remember 1, they're skip counting. So 1 all the way to 10, so right in the middle. And then this is the one that people asked about. They said, Mr. Where's 220? They know there's the 2, and then they go up and they go, it doesn't go up to 20. Well, that's okay. If the numbers don't go up to what you need, well, then you don't need it anymore. Don't forget, it's an airplane taking off, and all you know is you got to touch the dots that you were able to draw. And then it just goes up and up and up and up. It's going to try to reach that 20 somewhere up there. So just because you can't draw the number doesn't mean you did something wrong. It just means the graph wasn't set up for that. Okay? All right, so anyways, try number 6. Once you're done with number 6, again, you have plenty of time to finish today's classwork and to finish the homework. There is no excuse not to have so many missing assignments. All right, everybody, have a wonderful day, and I will see you soon enough.